And now the sample size is unknown, so n is what we are trying to find. T bar, the average time to install the n components, is given to me as 37.1, and the population variance, sigma square, is going to be equal to 5.0 square. If you were to look at the information that is given, the population follows a normal distribution and the population variance is given. That is why for my test statistics, I'm going to make use of a normal distribution. A normal distribution with a mean of 3.8 and a variance of 5.0 square over n. And of course, we can standardize this to z, which means that z is going to be t bar minus 38.0 divided by square root of 5.0 square over n, and this will follow a normal distribution of 0, 1. And according to the question, the null hypothesis is not rejected. So to not reject H0, I need to make sure that the p-value is going to be bigger than the level of significance, which is 5% level of significance. If I were to visualize the scenario on the bell curve, so the distribution of t bar with the center here as 38.0. It is a left tail test, so the critical region of 0.05 is going to be here, and 37.1 cannot be lying within the critical region, so t bar of 37.1 is going to be here, and the region that is going to be on the left hand side of 37.1 is going to represent our p-value. So this region here is going to be the probability that t bar is less than 37.1. This is bigger than 0.05. And since n over here is an integer value, how I'm going to solve for the range of values of n is I'm going to just insert the left hand side into the y1 of my calculator, then generate a table to look for all the possible integer values of n that will satisfy this inequality. So if I were to plug the left hand side into my calculator, n is the unknown, and in y1 it is the probability that t bar is less than 37.1. If I were to scroll down the table, when n is at 82, the probability is 0.05155. It is still bigger than 0.05. When it is at 83, the probability is 0.05052, still bigger than, but when it is at 84, the probability of this is 0.0495, and this is when it starts to get smaller than 0.05, so the maximum n can go is 83. But let's not forget that n is the sample size, so the least it can go is 1. That is why my answer for this is that n has to be less than or equal to 83, but it has to be also bigger or equal to 1.